Hello everyone. In this video, I am going to walk you through a complete end-to-end project where a chatbot on a website can automatically create a GitHub issue. The core idea is simple. A user describes a problem in natural language, an AI agent understands it, and a GitHub issue is created automatically. To build this, I am going to use an MCP server, an N8N workflow, and an LLM acting as an AI agent. I will start by explaining the MCP server code. Then we will look at how it fits into N8N. And finally, I will demo the whole thing end to end. Okay, let's start with the MCP server itself. This MCP server exposes tools that allow an AI agent to create GitHub issues. Instead of letting the LLM directly call the GitHub API, we give it a tool with a very specific controlled capability. This is exactly what MCP is good at, defining safe, well-structured actions that AI agents can perform. Okay, so this is the code walkthrough. At the top, I'm importing standard Python utilities, HTTPX for making async HTTP requests, and fast MCP, which is used to define and expose MCP tools. So MCP is equal to fast MCP GitHub issue MCP. Here I initialize the MCP server and give it a name. I'm naming it GitHub-issue-MCP. This name is what tools like N8N will see when discovering the MCP server. Next, I have a helper function to securely fetch the GitHub token from an environment variable _get_token. This function looks for either GitHub underscore token or GitHub underscore pat as the environment variable. If neither is present, it throws an error immediately. This is important because it keeps the secrets out of the code and enforces proper configuration. The next helper function, it normalizes labels and assignees. So the definition _normalize_list, this lets the tool accept either a list or a comma separated string. This is very useful when an AI agent is generating inputs because it doesn't always format the data exactly the same way. Then there is another helper function which is safe_JSON. This function is a small safety helper. If GitHub returns JSON, we pass it. If not, we still capture the response text so errors are visible. Now let's go to the heart of this MCP server, which is create_issue. This function does the actual GitHub API call. It builds the authorization headers, constructs the payload, and sends a post request to the GitHub issues API. If GitHub returns an error, we surface it clearly. Otherwise, we return the issue data. Now we will go to the MCP tool itself, which I annotated with @mcp.tool. This is our first MCP tool in this MCP server. This tool lets the AI agent explicitly specify the owner and the repository. Notice the function signature, it's very clean and structured. This is exactly where the AI agent sees when deciding how to call the tool. We normalize the inputs. We call the core issue creation function, the API from GitHub, and then we return only the fields that matter. That keeps the tool response small, predictable, and usable by the downstream steps. There is another MCP tool defined here, which is just for the convenience. In the first one, we are passing the owner and repo separately. But if you want to pass the owner and repo together in this format, owner/repo, the agent can use this particular function. This makes it easier for the LLMs to call the tool correctly. Internally, it will still use the same issue creation logic. Okay, finally at the bottom, we run the MCP server with mcp.run transport is equal to stdio. This starts the MCP server using standard input and output, which is perfect for integrating with tools like N8N. Okay, so now let's connect this tool to N8N. So in N8N, I have created a workflow. It starts with a webhook node. Webhook allows you to, it exposes an endpoint which can be called by a UI to use this workflow. It receives the input from the chatbot also. The webhook then passes the message to the AI agent. This agent is currently using OpenAI as the LLM, and my server, GitHub MCP client server, is also connected as a tool here. When the agent detects that the user is reporting an issue, it calls one of the MCP tools we just walked through, and once the issue is created, the workflow sends a response back to the webhook. I'm using the repository of this project itself for creating the issues, and as you can see, there is no issue created here so far. So let's see the whole thing working now. Let me execute the workflow, and I have also created a dummy product website with a chatbot in here. So as you can see, the user is sending the concern in a standard natural language. And when we submit this issue to N8N, we are basically invoking this workflow using the webhook. As you can see, the AI agent is coordinating with the OpenAI chat model as well as the MCP server also. And if I go to the open ones, I can see the issue has been created using that workflow with all the information. And this is what LLM has done. It has looked into the issue which has been passed as input, and it has created the steps to reproduce the expected result and actual result and called the MCP tool to create this issue. So this pattern is incredibly powerful. It keeps LLM focused on reasoning and moves real world actions into control tools. It is secure, auditable, and reusable. You can replace GitHub with Jira, ServiceNow, Slack, or internal APIs using the exact same pattern. In the next video, I will containerize this MCP server using Docker, build this entire N8N workflow step by step, and show you how to run everything locally or in the production. If you found this useful, please like the video and subscribe. And thanks for watching. I will see you in the next one.